Hello, my name is Bigham-Tsai, and this is the aquaponics system that we tried to create here at WMU to just have as an educational display. Here we're using a lot of fish, native fish species. Hello, my name is Bigham-Tsai, and I am here to show you the aquaponics system that myself and a few others have designed throughout this past year. This system was intended and designed as an educational system to introduce people and students into sustainable agriculture types, Michigan ecosystems, certain types of fish, and just overall environmental concepts. So in this video, I will be starting with an overview of this system, and then I will be making several other follow-up videos delegating how maintenance, upkeep of this system should be held, and all of the components that have gone into the design and problem solving of this system. This system overall is a unique design, designed by myself and fabricated here in the College of Engineering and now at Finch's Greenhouse. This was a team project where we brought on several other students to assist in the design and fabrication. Overall, this was grant funded by the Student Sustainability Grant and personally welded and fabricated by myself and one other, Brian Schreiber. Okay, so diving into the aquaponics overview, this is the overall system. We have many different components here. We have a grow bed here on the bottom and a grow bed here on top. They run in tandem. These are both soilless grow environments, meaning that water oscillates within these 8-inch grow beds to cover the clay plastic or the clay media and saturate the roots while still oxidizing them. Other than that, this is the bell siphon within this grow bed. Here, this allows the water to raise up and down. We have the grow bed up here has the same tandem unit. From that point, the water is then discharged into this black bin. This black bin is what we call the overflow tank. Here, this allows us to store more water to keep the system running for several weeks at a time without needing to be refilled. The water from the grow beds drain in a black tank. From the black tank, this is clean water that has been processed and by the grow beds and filtered. So from the black tank, we see water shoots into this fish tank. You'll see a pipe here that runs up from the back tank that is run by a pump and feeds into this fish tank. Here in this fish tank, the fish are able to utilize this clean water. We feed them and the water becomes dirty. The outcharge of this dirty water is through this pipe we see in the middle. This is the discharge from the fish tank. From that discharge, it runs down the side, under here, parallel, into this blue tank. This blue tank is the solids filter settlement. Currently, we do not have a solid filter in there, but we are going to put one in there. Here, we filter out any gunky matter so that physical gunk doesn't hit the grow beds and cause deoxidation or whatnot. From this blue pump, from this blue tank, it overflows gravity-based into this yellow tank. This yellow tank is where we house another pump just to not disturb the solid settlement in this blue tank. In this yellow tank, we have another pump that shoots up and splits up at that T filter right there to this top grow bed and the bottom grow bed here. That allows this nutrient-rich water to be taken from the fish tank, utilized by the plants, and sent clean back to this black tub and to the fish tank. That is the overall flow diagram. More into the overview, we have many mechanics, many electrical components so far. We have several pumps running here that just to get turnover within the tank. We have an air pump behind this root structure. We have a lighting board that we created in the back and lights on top to show this. And then also there are 2 cords for our main pump. So if you follow me over here, I can explain the electrics. So going over here, this yellow pump here marked with the yellow tape is the pump that sends the water from the yellow bin up into the grow beds. This pump on this white cube is the lighting. This here is a water level detector pump. So if the water level is too high or too low, it will shut on and off this outlet. Here, the yellow used to be plugged into this outlet, and we're going to try to put the yellow back into this outlet because the yellow pump will sometimes run dry if not enough water is going to it. Therefore, if it's running dry, we want it to shut off to conserve the pump. But that is something to be troubleshot later. This is to one of our pumps in the fish tank. Nothing really important there. It's the thick, sturdy one. This one with the white tag and with white electrical tape is the pump that sends from the black grow bed into the water supply. And this is another small pump within the fish tank. So again, these 2 pumps, the one with the wire here and this pump, that you will see they feed directly to the inside of the fish tank. Therefore, these are just keeping the flow within the fish tank a little turbulent. These 2 pumps are the main pumps. These 2 both need to be plugged in and running right. The one with this tag and the white electrical tape on it, and the one with the yellow electrical tape on it. The yellow is for the yellow bin going to the grow beds, and the white is for the black bin going to the fish tank. Those are the 2 primary pumps that keep the system in oscillation. And coming back in here, we have our steps for the design and grant. So for anyone who is interested, I thought I would just walk down all the steps that came to fabricate this process and go into it. It's been 1.5 years since we've started working on this. Prior to this, I was personally researching aquaponics and different aquaponic systems. However, this is a unique design that's never been seen before in its 3-dimensionality. Most aquaponic systems are more industrial and as a result are more based on gravity-based flow from one side to the other. However, we really tried to make this one elongated and vertical, meaning it does have a higher energy requirement and there are more pumps in use. So this is an unseen design. Also, there are other components of this that are unique. We're using native fish. We're using plants that have not necessarily been in aquaponics before, more to just be an educational display and of interest to a wide range of environmentalists. The grow bed design is unique. That's something that has never been seen before. And also doing this in a more pretty way as opposed to industrial, having the exposed fish tank and exposed grow beds is rather uncommon as well. So as a result, we had to design this thing. Me and my partner Brian at the time, under the advisement of several WMU faculty, came up with this design, and then Brian was able to work with me to put it into a CAD drawing. So we have automated computer design of all the steel and all the framework. I ran a structural test to make sure that it was structurally sound and sturdy. It is significantly okay. This holds over 2,000 pounds of water weight, so that was important. From that process, I was able to write a grant and allocate about nearly $5,000 to the system. From that point, that went on to purchasing the tank, which is from Petco, buying all the metal from Rescued Metals and a lot of materials from Lowe's and whatnot to be able to fabricate the system. Brian and I were able to weld the system together. We have physically done every aspect of the fabrication and putting together, including a wide range of machining techniques with wood, metal, welding, aluminum in some cases. Overall, we are able to draw on several resources as well. So for whoever upkeeps this, there are several university resources that have already been allocated into the system. The first of this is the College of Engineering. You could hit up Dr. Cavalli, the dean or associate dean, and remind him of my name and this project, and you will be able to have advice from maybe several engineering faculty and also the student engineering projects lab if a physical issue takes place. There is another resource at KVCC. We are on email basis with the head of the aquaponics system there, Ben. He is a great tool for knowing general aquaponics and overall questions if you want to reach out. There are several other people you can reach out to. Dr. Tiffany Schriever and her PhD, one of her PhD students, Adam Austin, is a good resource to reach out to in terms of fish health and ecosystem for fish. Chris Jackson, who is here now funding this project, is a good resource for plants and health. Obviously, the Office of Sustainability may be a key resource, as well as the Wetlands Ecology Lab under Tiffany Schriever, as I said earlier. Tim Palmer, under the Business Association, also has shown commitment to this project and may be able to help in the educational format as well. So overall, there are many resources here on campus to utilize within the system. I think that's